Okay, Calc, you should have this little half sheet of paper in front of you. If not, you need to get it from my sub. And we're going to fill this little half sheet of paper out. This is like your cheat sheet that has all 4 rules on it. And then the back side of it has these derivatives of trig functions. Don't worry about that yet because we have to learn those. So I just put those on there because this is your little cheat sheet. And this is what you get to use on your test. I will let you use it. So make sure that you're filling these in. And then we're going to go through it and we're going to label 1 through 12 on here. This homework sheet does have a backside that is 13 through 18, but wait to do those. Okay, so just do 1 through 12 for homework, but we're going to go through here and we'll label which one is which. So which rule you use for which problem. Okay, let's do your cheat sheet first. So here we go. Power rule. The formula for power rule is that if you have x to the nth power, the n comes down in front, x to the n minus 1, and that is it. Okay, now as far as parts go, n is the exponent. Okay, so I'm just going to label n as the exponent, all right? Now they want us to do the power rule on this thing, and there are 4 terms, 1, 2, 3, 4. And all we're going to do is we are just going to do each piece individually. So this 4 comes down in front. That's going to be, I'm going to call this y prime, actually. So I'll give the y a label. So this says the derivative of y prime, is equal to, that'll be negative 16 x to the third. This is going to be plus 15x squared. This guy will be minus 2. The x will just drop off, and then the 3 will be gone because the derivative of 3 will be 0. So I'm just going to do that. Okay, so that's the derivative. Power rule is awesome because you don't have to just simplify. You don't have to do anything, right? Okay, the product rule is for when you have 2 things that are being multiplied, hence product, right? So f times g becomes f prime g plus g prime f, okay? Now, for this problem, I understand that we could potentially just FOIL this out and then use the power rule, but I'm warming you up and I'm giving you an easy problem to do the product rule rather than an ugly problem that you couldn't use the power rule on. Does that make sense? Like, you can't use the power rule on every time you do a product. So I'm giving you an easy one rather than giving you a hard one that you couldn't do the power rule on. Whatever. Anyway, so in this case, f, I always designate f as the first piece and g as the second piece, okay? For the product rule, it doesn't matter which one is which, but it does matter for the quotient rule. So I just get into good habits up here by doing f is the first one, g is the second one, all right? So we need f prime g plus g prime f. All right, I'm going to write kind of like ish small because we're going to have to simplify this thing. All right, I'm going to zoom in. F prime is the derivative of this guy. Oh, that's not too bad. That's nice. His derivative is 2. G is just this full thing, 3x to the 4th minus 8. G prime is the derivative of this guy, which is 12x cubed. And f is just that full thing, 2x plus 5. That's not too bad. I got to distribute my 2 through. So that's 6x to the 4th minus 16 plus, if I'm going too fast, make sure you pause me so that you can catch up. If I distribute this guy through, that makes 24x to the 4th plus 60x cubed. And then all I have to do is simplify. And I'm going to go, I don't know, 6 and 24 is 30x to the 4th plus 60x cubed minus 16. There you go. Make sure you're filling this cheat sheet out because you get to use him on your test. Oh, let's call him y prime. Let's give him a name, right? Because he was called y before. So y prime is his derivative. All right. Next, formula for quotient rule. If we have an f divided by a g, it is f prime g minus g prime f all over g squared. That's how you do his derivative, okay? For this problem, f has to be 8x, g has to be x squared plus 9x minus 3, and let's go ahead and do this. All right. F prime g minus g prime f all over, I'm going to go ahead and just write out g squared. Ugh, that's disgusting. We are not FOILing that or multiplying that out. Gross. All right, let's do it. F prime. The derivative of 8x is just 8. Then we've got x squared plus 9x minus 3. Okay, that's g, right? G just stays. Now we do g prime, which is the derivative of this guy. So 2x plus 9, that's his derivative, times just f, normal f, okay? And now we're going to simplify just a few things. I'm going to distribute my 8 through, right? So maybe I'm going to go over here. 8x squared plus, no, yeah, plus 72x minus 24. Okay, now don't forget this minus sign needs to be distributed through. So, actually, you know what? Here's what I'm going to do. I'm going to change this to a plus, and I'm going to put my negative with my 8x. And now I can just distribute him to those two. So that'll be minus 16x squared minus 72x. Does that really cancel out like that? Over the bottom, blah, 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 right? Okay, 8x squared minus 16x squared is negative 8x squared. 72x minus 72x cancels. And so then I have minus 24 all over x squared plus 9x minus 3 squared. That's what he is. Okay, that was not that bad. The bottom looks uglier than the whole thing. Interesting. So there's that. All right, chain. This guy's my chain rule. My chain rule says that if I have, let's say, x to the nth power, right? But x is standing for something that's other than x, like this could be x plus 6, or this could be 4x. Don't write that down. It could be something other than x. Okay, I have to pull the n down in front, leave the x, do the n minus 1, but then I have to multiply by x prime. So I have to take the derivative of the inside. Okay, this is just the inside normal, and then this is the derivative of the inside. Okay, so in this case, my inside stuff is 3x squared minus 7, just the inside stuff, okay? And this is x prime. If I'm taking the derivative of the inside, this is 6x is what he will be, okay? So this part right here will be a 6x. So this is just helping you get your middle step done. Now, why do we have to use the chain rule on this? Because it is a function inside of another function. It's a composite function. One function is composed inside of another one. So this is a quadratic function. That's 3x squared minus 7 is quadratic inside of a cubic function. Okay, so that's when we use a chain. All right, so here we go. The 3 comes down in front. I leave the 3x squared minus 7. But now that 3 becomes a 2 because I'm subtracting. And now I have to multiply by the derivative of this inside, which we just said was 6x. And the only thing I do to fix him is I take this guy times this guy. Now, why can't I take this guy and distribute him through? Like, I didn't say that before. Why can't I not do that? It's because he's to the second power, right? So that can't happen. Now, the only time that can happen is like, let's say we were taking the derivative of 3x squared minus 7 squared. Don't write this down, okay? But just watch. If I'm taking the derivative of this, okay, the 2 comes down in front. 3x squared minus 7, now that is to the first power, times 6x, because that's the derivative in the inside. Now I could distribute that 2 through, because now he's to the first power. But I can't if he's squared. I have to do exponents before I do multiplication, right? That's PEMDAS, okay? So just FYI, that's how that works out, all right? Okay, let's fix him. 3 times 6x is 18x. And then I have 3x squared minus 7 squared. Can I get it? Do I have to put a parenthesis around the 18x, or can I get away with not? You can get away with not because this is only one term, right? If this was like 4x squared plus 18x, I would have to do parentheses, right? But this time I do not, because those are all, you can if you want to. If you want to just be safe, that's fine. So there's that. Okay, this is your cheat sheet. That has all 4 of the rules on it, plus the trig function rules on the backside, which you don't know yet because we haven't done trig functions. So there's that. All right, let's go to this. I'm going fast, so if you need to pause me, go for it. Okay, we have on this page, this is your homework assignment. Again, you don't have to do 13 through 18 yet. We'll add those, but try to do 1 through 12. Some of them are going to be uglier than others. Some of them are going to be really easy. Okay, so let's try to see which 3 are power, which 3 are product, which 3 are quotient, which 3 are chain. Okay, so I'm just going to start with number 1, and let's see what we can figure out. Okay, this is x squared times this junk, and times means a product, so this is going to be a product rule. Okay, now this part is going to be the f part, x squared is going to be your f part, and g is going to be this part, right? Okay, so try to figure out your f prime g plus g prime f, all that good stuff. Okay. This one, number 2, see if you can figure out what this one is. He is a function inside of a negative 2 power. So he is a chain rule. Okay, so we've got 1 product, 1 chain. All right. This guy, this is easy. This is just a power rule. There's nothing fancy about him. Power. So now we've got a power rule 1. Okay. And this one. We could technically, if you want to be fancy, you could move this up to the top. Malaya. Shh. Malaya.
What?
Be quiet. I'm recording. We could move that thing. I'm recording. Be quiet. Shh. They don't need to hear you sing. Okay. All right. We could move that thing up to the top if we wanted to, and it would look like this. He would be in the negative first power, right? Like that thing. And then I could do the whole chain rule thing if I wanted to, but I'm not going to do that. I'm going to treat this as a quotient. We're going to do quotient rule on him. Oh, now we're 1. Q-U-O-T. Yep. We have 1 for each. Okay, let's go down to the next one. This guy. I could FOIL these out. That's true. I could multiply that all together and use the power rule, but we want to use the product rule. Okay, so there's 2 for product. All right, this guy, 6. What do I do with that? Anytime you see a square root, make him to the 1/2 power. So that is going to be a chain, because it's a function inside of a function. So chain rule. Next, 7 is a function inside of another function. So this is another chain. Chain is out. We shouldn't have any more chains, I don't think. Okay, number 8. Number 8. I'm trying to think. It looks like a quotient, but we've got 2 more quotients going on right here and right here, right? This is definitely a quotient, and this is definitely a quotient. So this is where I got to be picky. You could do 4 quotients if you want to, but I would personally do this as a power rule, honestly, and I would move him to the top just because he's easy. So this would be 3x to the negative 3rd power, and then you do your power rule and fix him. Okay, so I would treat that as a power rule because I don't think I have any other power rules on here. Well, besides, yeah, the ones. Anyway, so that's a power rule. This one is the 3rd power rule because this is to the 1/4 power, right? Negative 2 is just chilling in the front. Move your 1/4 down in front, all of those things, right? Try to do that as a power rule. Okay, and then that means this last one has to be our last product, I think. Is that enough? For 3 products, 3 chains, 3 quotients, 3 powers. Yep, product rule for that. Again, I understand you could FOIL that out. If you want to FOIL that out and check your answer and do the power rule, go for it. But I think they want us to do the product rule. Okay, all right. These last 2 back here, if you want to attempt them, these are fancy. This last one, these last 2 here, 13 and 14, this is where it gets really difficult, and we will do these moving forward. But this is weird because I have this guy to the 3rd power, which says chain, but then I have times x, which says product. So which one do I do? You actually do both of them. This is a chain rule inside of a product rule. Okay, so we'll talk about how you do those and what the rule is for that. All right, here I have a quotient rule, but this is a chain rule. So this is a chain inside of a quotient, right? So we'll talk about how those work and how those operate, and how then they're kind of fun, actually. But for now, you just try to do 1 through 12 for homework. Okay, goodbye.